Let's resume. In the previous video, we talked about trigonometric equation problems when we have both sine and cosine functions. Well, if you have both sine and cosine, or the linear term sine and cosine, usually you're going to be in trouble, or you'll have to look the other way like tangent or something else. But if it is sine squared or cosine squared, then no problem there, because you can always use Pythagorean identity cosine squared plus sine squared is equal to 1, and express cosine squared as 1 minus sine squared, or sine squared as 1 minus cosine squared. For example, here's a nice problem. We have both sine squared and cosine squared. Which one is right and which one should be converted? The linear term gives you the answer. Sine of x with first power, you cannot change this one. So everything will have to be changed into sine of something, not cosine. Here we go. This one dictates the direction of the problem, and consequently this cosine squared can be rewritten as 1 minus sine squared. And what do we have? We have a quadratic equation of sine function. What do we do now? Easy. Break up everything, take the like terms together, and simplify, and eventually factor the quadratic equation of sine, and you're going to get sine of x equals to negative 1/3 from the first factor, and sine of x is equal to 1 from the second factor. Good? Alright, and then what we do? From the first factor, we can take arc sine, and then we have arc sine and pi minus arc sine. As a matter of fact, let's see, arc sine of negative 1/3 is the same as negative arc sine of 1/3. The reason is because arc sine is sine is a odd function. So arc sine of x is 1/3, so sine of negative x is negative 1/3, kind of like that. So you can put this negative outside. That's how we get pi plus arc sine of 1/3 rather than pi minus arc sine of negative 1/3. But it would have been okay if you wrote pi minus arc sine of negative 1/3. As a matter of fact, I kind of regret I did this simplification. I made this problem overly complicated that way. It would have been perfectly fine with this. And then that's the next solution. Oops, not from there. The next solution is coming from the second factor. Sine of x has to be equal to 1. And if you look up the trig diagram, because sine value equals to 1, that's coming from one of those elementary angles, basic angles. That takes place when x equals to pi over 2 and nowhere else. That's when, as a matter of fact, those 2 points, red and blue points, collide and then become just single point. Let me show you. Oh, okay. All right. This is not really the graph of sine function. Here I just showed you the graph of this entire composite trigonometric function. Y equals to 3 sine squared x plus 2 sine of x plus 6 cosine squared of x, and set it equal to 5, and then we have these solutions. Oh, actually the collision is still visible. This black point you see is actually coming from sine of x is equal to 1, and if you move just a little bit to the right or left, you'll see the same y-coordinate values, but they're going to just collided right at this floor of the valley, and it turned out a single solution. Okay, that was a good review, and let us now move on to the new topic here. We already did Pythagorean identity problem, as a matter of fact, at the end of chapter 5. So this was all the review. That's why I went pretty quickly. Now let's slow down a little bit and consider some problems that we'll have to use either double angle equality of sine or double angle identity of cosine. Especially the double angle identity of cosine will be particularly useful, because cosine of 2x is interchangeable, pretty much. Either it becomes cosine squared or either it can become sine squared. Oh, I forgot the factor of 2, excuse me. 1 minus 2 sine squared of x. Depending upon what kind of linear term I have, I'll have to use either this one or that one. Okay, let's go over to the first problem here. Cosine of 2x minus 3 cosine of x minus 1 is equal to 1. Minus equal to 0, excuse me. Now we have cosine of 2x and then we have 3 cosine of x here. So which is wise? Should we change this cosine of 2x into 2 cosine squared of x minus 1, option number 1, or 1 minus 2 sine squared of x, option number 2? I hope everybody guessed it. Option number 1 is better. Change everything into cosine function. Now, if you look at the second problem B, we have 5 sine of x plus 3 cosine of 2x minus 1. In this case, which option do I have to use? 1 or 2? In this case, option number 2 is better. 1 minus 2 sine squared because of this sine function here. In other words, the linear term of sine and cosine dictates the direction of the problem, and cosine squared or sine squared are interchangeable, and also cosine of 2x can be either sine squared or cosine squared depending upon the circumstance, and that circumstance is dictated by the linear term. Okay, let's finish problem A and then let's finish problem B. In problem A, cosine of 2x can be rewritten as 2 cosine squared of x minus 1. And this is cosine. So what do we have? We just have a quadratic equation of cosine. Breaking up all the parentheses, taking like terms together, and so on and so forth, we have the standard form and we have the factorization. So cosine of x is equal to either negative 1/2 or cosine of x is equal to 2. I hope everybody sees immediately that cosine of x equals to 2 is meaningless. Cosine function is bounded between negative 1 and positive 1, so it cannot reach 2. So that's extraneous, that's out. And cosine of x equals negative 1/2 from this one. And by looking up the trigonometric diagram, when do we have the first coordinate cosine part equal to negative 1/2? Let's see, 2 pi over 3 and 4 pi over 3, aren't they? 2 pi over 3 and 4 pi over 3 plus 2k pi. Or you can write 2 pi over 3 and negative 2 pi over 3 plus 2k pi. That's fine, perfectly fine too. Because negative 2 pi over 3 plus 2 pi is 4 pi over 3. So changing the k value, you can put arbitrary integer there. So negative 2 pi over 3 or 4 pi over 3 generate actually the same thing. Now, if your domain is specified, then of course you have to find out a solution within that domain. One more exercise. Let's go over to the second problem here. We have sine function here. Consequently, this cosine of 2x becomes this one. We want sine. Okay, here we go. 5 sine of x times 3 cosine of 2x. And this cosine of 2x is equivalent to 1 minus 2 sine squared. So what do? Break up the parentheses, take the like terms together, simplify, factor. In the end, we have this 2 sine of x minus 1 times 3 sine of x plus 4. In the end, we have sine of x equal to 1/2 or sine of x equal to negative 4/3. The latter is of course extraneous because sine function is always bounded between negative 1 and positive 1. So sine of x equals 1/2. By looking at the trig diagram, let's pretend you did. Pi over 6 and 5 pi over 6 will be your solution. Pi over 6, that's straightforward, and pi minus that is 5 pi over 6. Or you can simply find out two solutions from that trigonometric diagram. Easy enough? I hope so. When you have double angle of cosine, it is matter of making a good selection. 2 cosine squared minus 1 or 1 minus 2 sine squared. Depends upon what kind of linear term I have. Do I have cosine or do I have sine? There are more problems, but those are kind of redundant, just for repeated exercises. And we have a little bit of time left, so let's move on to a problem that you'll have to use double angle identity for sine. Okay, let's go ahead and do that. Sine of 2x minus tangent of x is equal to 0. So on the left hand side, let's apply the double angle identity for sine. And to the second term, apply the quotient identity. Tangent is sine of a cosine. Now what do we have? We have a denominator, so usually the first thing you'll have to do will be kill off the denominator by multiplying everything by cosine. So if you do that, then you get the second equation, cosine squared in the second term, and then cosine disappeared from the denominator. What do we have now? We have common factor. Factor sine of x out. We have 2 cosine squared minus 1. So setting the first factor equal to 0, we have sine of x is equal to 0. We are going to get either 0 or pi. Let me show you the diagram. When theta is 0 or theta equals to pi, when angle is 0 or pi, the second coordinate is 0. Okay. How about the next? 2 cosine squared is 1, so cosine squared is 1/2. Consequently, cosine of x has to be plus or minus 1 over square root of 2, or plus or minus square root of 2 over 2. And what are they? Pi over 4, 3 pi over 4, those give you square root of 2 over 2, or 1 over square root of 2. And then 5 pi over 4 and 7 pi over 4 give you negative of those. We have plus or minus, so they all qualify. Plus or minus pi over 4, plus or minus 3 pi over 4 is the way I wrote. That's equivalent because you see, if you take negative pi over 4, that's equivalent to 7 pi over 4. And negative 3 pi over 4 is equivalent to what? 5 pi over 4. Yes. And 2k pi will cover everything. Well, there were some problems like that, and then you can actually do further problems. Some application problems kind of like these. Find out crossing points, and that kind of problems could be associated with some cool picture like this. And blue is cosine function, red is cosine of 2x, and you have to find out the crossing points, the x coordinate of those values, and then plug in the x value to either y equals cosine of x or the other one to find out y coordinate, and you get all the crossing points. How do you do that? All you have to do is just set these y coordinates equal to the same. Cosine of x is equal to cosine of 2x. This is what we want to do. Cosine of 2x is equal to cosine of x. What do we have? We have a trigonometric equation. And cosine of 2x, you can change it into something which you'll have to do. How about the next problem? Tangent of 2x and 2 sine of x. Okay, setting both of them equal to each other, we have this kind of graph, and then we expect many solutions here. As you can see, we have many crossing points. And of course, crossing point with a vertical asymptote, that doesn't count because vertical asymptote is not part of the graph. So we have 1, 2, 3, 4 solution. I think 1, 2, 3, 4 solutions from 0 to pi, 0 to 2 pi. And let me see how do you solve that. Tangent of 2x is equal to 2 sine of x. And you'll have to use some double angle identity for tangent and then some simplification Okay, the rest is left to the students.